The Soviet N-1 was mainly known as the rocket that failed to get Soviets to the moon in the 1960s. We're going to take a brief look at why this rocket was biting off more than it could chew on the next Soviet edition of Vintage Retrospect. Hello comrades, I'm Chad, your host for this edition of Soviet spaceflight history. So many of you probably haven't heard of the N-1 rocket, but even if you have, the surprising thing about this rocket is that it was designed originally for interplanetary travel. So this rocket was originally planned to go to Venus and Mars, and I'm not even kidding, but in 1964 things took a wild turn. Sergei Korolev, the brains behind the Soviet space program, answered the challenge of beating the Americans to the moon since the 1962 moon speech by President Kennedy. So the N-1 rocket had to scrap the idea of flyby planetary missions and focus on building a spacecraft lander combo, which was called the LOK, and launching it with the N-1 to land crew on the moon. I will touch more on the LOK in a later episode. Now, the Saturn V in comparison could lift around 140,000 kilograms to low Earth orbit, but the N-1 could only lift 95,000 kilograms to low Earth orbit. The first stage, called D Block A, used a total of 30 NK-15 engines, and the total combined thrust was around 45,000 kilonewtons of thrust, which was the most powerful rocket stage ever built, even surpassing the Saturn V. This, of course, have been recently beat by Space X Super Heavy Booster in 2023. The N-1 didn't use complex steering gimbals like the Saturn V's F1 engines, so in order to provide 3-degree steering required, pitch and yaw was actually performed by differential thrust variations. Roll control was actually provided by 6 small nozzles that swiveled. This rocket sounds epic until we learned what happens next. The system used in the engine clustering called CHORD, or which translates to Control of Rocket Engines. The first test flight was tried on February 21st, 1969. Mind you, this was an all-up test of all the stages, which means there was no ground testing of the engines, which is crazy, as the Soviets always are, right? During countdown, the rocket lost 2 engines at first, engines number 12 and number 24. Later, after liftoff, engine 12 was sensitive to vibrations, causing itself to tear apart from a pipe puncture in the gas generator and leaked hot gas into the propellant. Then engines 3, 21, 22, 23, and 24 caught fire, and CHORD then shut down those engines. The rocket lost thrust and crashed. The second launch was on July 5th, 1969, and just a few seconds after liftoff, 4 engines shut down. After T+8 seconds, CHORD shut down more, and about 200 meters high, the rocket just couldn't keep up with the thrust-to-weight ratio, and the rocket strafed into the launch pad. The third launch was far in between here, with its attempt on June of 1971. It looked great until the roll stability decided to go bonkers. This commanded CHORD to shut down all NK-15 engines, and of course, this rocket fell back to the ground. Finally, the fourth launch. And this test looked more promising at first. Then at T+77 seconds, which is the furthest this rocket has ever flown, things go weird. CHORD did actually shut down the Core 6 engines as planned, however the first stage decided it had had enough, and a fire broke out on the bottom of the rocket, of course performing a rapid unplanned disassembly and rained debris on the ground. Most of these failures revolved around CHORD's lack of dynamics to handle acoustics and the stresses of aerodynamic flight. The interesting thing is with the 30 engines is there are 30 points of failure as well, and it wasn't even a surprise that the N-1 failed as often as it did. But then look at Starship with the 33 engines on its first stage. Those single engine failures were about spot on with Starship's early development, but SpaceX is using smarter engine clustering systems to handle the mass complexity of this mega rocket. Of course, engine clustering of this scale allows a few engines to fail, yet allow the vehicle to still achieve orbit. Redundancy is key in spaceflight, so the Russians were definitely onto something. But just that it was implemented in the Russian way.
A big problem in the Russian space station because I don't want to stay here anymore.
So what are your thoughts on the Soviet mega rocket? Was it a complete waste of money and time? Or did this project give rocket engineers valuable data that proved useful in future rocket development, such as the Proton or even iterations of the Soyuz rocket? Let me know down below, and also don't forget to subscribe so that others can realize that the Soviets really did try to go to the moon. I am your host, Chad, and I will see you out on the launch pad.